Assalamualaikum and hi, my name is Adila Shaira binti Karukanizam. My ID is MA25153 and I will talk about our CAD project, which is about traditional houses in Malaysia. Malaysia is known for architectural designs in traditional houses. There are many types of traditional house, but our project are about traditional Bugis house. Traditional Bugis houses are form of vernacular architecture introduced to Malaysia through Bugis migrations, particularly in Johor and Selangor. The houses are typically elevated on steel, constructed using timber, and designed with steeply pitched roof. Traditional Bugis houses in Malaysia represented an important part of the nation's culture and architectural heritage. However, many existing design records of traditional houses are available only in printed form or through physical observations. These printed documents and manual drawings are vulnerable to physical damage, such as termite attack, aging, and environmental deteriorations. And in many cases, no digital or soft copy versions are available for long-term preservation. From an engineering perspective, the architectural designs of Bugis houses demonstrate efficient spatial planning and climate responsiveness. Large roof overhangs protect wall surface from heavy rainfall, while open internal layout improve airflow and thermal comfort. The objective that I can say from this project is to design a traditional Bugis house using SolidWorks software, to apply component-based engineering design principle in the modeling, and to produce complete part drawing, exploded view, and fully assembly model of the traditional Bugis houses.
Assalamu alaikum. This is Mashghan Abdullah, matric ID MA25167. Today, I'll be talking about the skeleton structure design of a Bugis house, which is the floors, columns, and beam system. A Bugis house is elevated from the ground due to heavy rains or animal attacks or any other environmental reason. So the house is elevated using columns and concrete foundation at the beginning of the column to prevent humidity to soak into the woods, and then the beam system is used to connect those columns and prevent them from moving around and stabilize the whole structure and distribute weight to each column equally. Then the floor is placed above the beams to finalize the structure and distribute the weight into different beams, then into columns, and connecting all components together. And I will now show you in SolidWorks how I designed each part and their uses. This is the SolidWorks view of the Bugis house skeleton structure design. As you can see, this is the column system of the Bugis house. It's made out of 5 columns by 5 columns. Each column is 2000 mm in length, in height, and 1678 in width, and 2678 in length. This column is used to elevate the house from the ground, and it usually have a concrete foundation at the beginning of the column to isolate the house from the humidity and rain and prevent water to soak into the foundation. To the beam system, we added a second layer of beams to even help stabilizing the build and to simulate the real house that we use as a reference, as you can see. After finishing the column system, this is the main beam system. The main beam system is used to connect the columns horizontally to create a grid of frames that provide stability and prevent the structure from swaying, and they act as the primary support for the floor system, and they help distribute the weight among different columns. The main beam system, we have to construct the secondary beam system. As you can see, the secondary beam system is placed perpendicularly across the main beams. The rule of the secondary beams is to distribute the floor load evenly and reduce the span for the floor planks and prevent the floor from sagging or bouncing when walked upon, and distribute the weight among different beams to the columns eventually. Skeleton structure design for the bogus house is the flooring. The floorings are the decking layer of the substructure. The planks are modeled with small gaps to reflect traditional craftsmanship and uh, that allow airflow and prevent humidity to accumulate in the structure. I use the liner pattern feature to ensure precise and equal spacing between floor planks. And this is the final look for the project.
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Muhammad Harith Irshad bin Muhammad Azam, Metri ID MA25162. So now I would like to tell you how to build a Porsche in SolidWorks. So the task is to design a complete design of the Porsche structure in with perfect assembly techniques. So we move to the stairs. So the stairs it help people to go to the further different floors. So first of all, we need to use the 3D sketch. Uh, you just click on sketch. You can find the 3D sketch here, and then you choose the front plane to draw it. Supposedly it look like this, and then after that we draw the steps there. So this is how I draw them. And then uh, I will extrude them, and then we draw the beam. The beam is used for the safety purpose to help the elders and prevent kids from falling. So we use on the front plate and extrude space. It's also the same one for the opposite side of the beam, but we use in the different plane, which is I create it on the reference geometry. So next is how I put the Porsche is. The Porsche is used for the social activities such as like guests visiting us during the special days or something else. And then we there are some people use for this as storage place that need to save something. And then some people use this as a resting place uh, to rest their body or after a tiring day. So this is the trimetry view of the Porsche, and this is the front view. This is back view. This is the side view of the Porsche. So next we move on to the exploded and collapse view, collapse animation for the Porsche. So this is how I put my Porsche. That's all from me. Thank you.
This is our group roof design. Roof design is critical element in traditional Bugis houses as it directly influences structural loading and environmental performance. The steeply pitched gable roof facilitates rapid runoff, and reduce the accumulations of dead loads during heavy rainfall. In addition to structural efficiency, roof overhang and fascia board play an important role in shading and weather protection. Extended overhang reduce direct solar radiations on wall surface and minimize rain penetrations into interior space. Roof trusses, known as kuda-kuda, distribute roof loads evenly to the supporting beams and columns, ensuring structural ability while maintaining a lightweight construction system. In Bugis traditional houses, known as bola, the roof overhang is a critical architecture feature designed to manage the tropical climate, offering protection from heavy rain and intense sunlight. These houses, which are elevated wooden steel structure, feature large overhang eaves that extend significantly beyond the exterior wall. This is our final product for the roof. As you can see, I assembled the main roof part with the board, fascia, and the overhang one. But the overhang one is supposed to be in the wall, so it was not shown in this roof assembly. These are the reference that I use, and that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wantar Habib Muhammad, matric ID MA25160. Now I will explain about my part, which is door, window and ventilation. Now I will show how to create a door or window using part in the SolidWorks. First, we go to sketch and we choose rectangle and create a rectangle. After that, we go to smart dimension and we measure the height and the width of the rectangle. We go to feature and extrude boss base. For the tip, we go to 50 and right click so we can see the door was created. And after that, we want to create a pattern for the door. First, we create one pattern using rectangle and we measure using smart dimension. For the height, I choose to 500. We also need to measure the edge of the pattern to make it perfect. After we measure the edge, we extrude cut. I choose to 25 tip to extrude cut the pattern. I check first and right click. So that we want to copy the pattern using linear pattern. For direction 1, we choose the top of the pattern and we put the measure for the spacing. And the number of direction 1 is 2. So for direction 2, we choose edge of the pattern, and we choose feature and face is extrude cut to pattern it, to linear pattern it, and we can see it was successful. We have 6 pattern right now, and we change the material of the door. I choose thick for the door. We apply and close, so we can see the door change, the material of the door change into the thick. So we also can use this method to create the window. Now I will teach how to sketch a pattern for a ventilation. First, we go to Tools, Sketch Entity, and Sketch Picture. After that, we find the picture of the ventilation pattern, and we measure the length of the picture to make the measurement is realistic. And we zoom to the pattern, and we use spline to copy the pattern from the picture. We need to point where we want, where the pattern we want using the spline. We go one by one, point until it looks like a pattern we want. So we need to point until it's close the spline. So we need to sketch the find the pattern we want until it go perfect like this. After that, we create a board for the pattern like this. Make sure the pattern inside the board. After that, we extrude boss the pattern. So we can see the pattern inside the board, and we need to extrude cut the pattern into the box. So as you can see, the pattern extrude cut to the box like this. After we extrude cut the pattern into the board, we need to mirror the pattern to make a perfect geometry pattern. We use mirror first. We right click at the edge of the pattern, and we choose the cut extrude from the pattern, and we can see it mirror into the left side of the pattern, and we use the same thing to mirror into the bottom of the pattern. Make sure we right click, we click at the geometry pattern to make it successful like this. After we successful create a pattern, we use linear pattern to copy the pattern to the board. like this. And we see the measurement. Make sure the copy is perfect, and make sure we click a geometry pattern. After that, we click, so we can see it's successful copy to make a pattern for the ventilation.